So here I consider question 24, and the question reads, that is from paper 1, Kenya Certificate of Secondary Education 2019, paper 1, and the question is question 24, which reads, let's get it. The equation of a curve is y is equal to x cubed plus x squared minus x minus 1. Part A, determine the stationary points of the curve. That's 3 marks. 2, the nature of the stationary points in A, 1 above, 2 marks. Then part B, determine the equation of the tangent to the curve at x is equal to 1. That's 3 marks. Then part 2, the equation of the normal to the curve at x is equal to 1. That is 2 marks. So let's consider the solution. So as we have seen, we are given that the equation of a curve is y is equal to x cubed plus x squared minus x minus 1. That's the equation of the curve. Then we are asked to determine the stationary points of the curve. So for us to determine the stationary points, we would need then to get the derivative of this and equate it to 0. The reason why we are doing that, by getting the derivative of a function, we are getting rate of change. And rate of change of a curve applies at the points where it's making a turn. So it will be making a turn where it's maximum, it has attained the maximum height, or at a point where it has attained the minimum height. So whichever way a turn occurs at a point where there is the rate of change, actually where we measure the rate of change, and that rate of change at that particular case, if it's optimal, then we consider it to be 0. So here, first thing that I'll do is to try to get the derivative, which will be dy dx, and so dy dx there will be 3x squared plus 2x minus 1. That's the dy dx of this function. It will be this. So for me to find the value of x, I want to find, because this is a curve, for me to find the value of x at that turning point, I'll need to equate this to 0. Then that will give me the value of x at that turning point. So then I should then say that 3x squared plus 2x minus 1 is equal to 0. Then what I need to do next is to find the values of x that satisfy this equation. So I realize that I need two values whose product is -3 and sum is +2. So these values have to be 3 and minus 1. 3 and minus 1. So I'll say 3x squared plus 3x minus x minus 1 is equal to 0. Then I factorize 3x so that I have x plus, this is now x plus 1, yeah? 3x plus 1, yeah? There's 1 here, minus, then I have minus 1, and then x plus 1, like this, is equals to 0, yeah? So that should mean that 3x minus 1 in bracket x plus 1 is equal to 0. And so, if I bring that this end, what this implies is that it's either 3x minus 1 is equal to 0 or x plus 1 is equal to 0. So, we take the case where 3x minus 1 is equal to 0. That should then imply that x is indeed a third. And if we take x plus 1 is equal to 0, that then should imply that x is minus 1. So the two values of x that we have are a third and minus 1. Well, that's not all. We then need to check the corresponding values of y when we have those particular values, especially when x is a third and when x is negative 1. So let's say when x is negative 1, this y, which is this, will be y will be, which is this, will be, because it's given as x cubed plus x squared minus x minus 1. So if I substitute minus 1 in every other part here, I'll be having a negative 1. Here I'll be having plus 1, then plus 1, then minus 1. So this means ready, just terminate. This is minus 1. Then this square will be plus 1. So really this is 0. Then minus x will be plus x. So this is plus 1, because minus 1, that's plus 1, and then minus 1. So 1 minus 1 again. So this is 0. So y is 0. Now, when x is a third, then y will be, that is 1 over 27 plus 1 over 9 minus 1 over 3 minus 1. If you work this out, if you work that out, you should be able to get minus 1, 5 over 27. Minus 1 and 5 over 27. So that basically gives us the points, the 2 points that we want. So it means that the 2 points are minus 1, 0, and a third, minus 1, 5 over 7, or 5 over 27, 5 over 27, minus 1, 5 over 27. So, having found those, now we now know for sure that these are the stationary points. These are the stationary points, but we don't know yet what the nature of these particular points, whether this is a turning point, whether this is a maximum point or a minimum point, or whether there's a maximum point or a minimum point. So let's move on and see. We shall identify the nature of these 2 points, the stationary points. So Roman 2 exactly says we need to determine the nature of the stationary points we have just found in A above. So for us to find the nature of these stationary points, it is worth trying to find the second derivatives, because the second derivative is the one that will give us a sign that will guide us on whether that particular point is a maximum or a minimum. Because you see, if it's a maximum, we should be seeing some upward movement, some positive movement, then we get to the maximum point, then we see a negative movement. But if it's one that is a minimum point, we should see it moving from a positive going to negative as such. Yeah. So let's okay. What I mean is this and this. This will define the minimum if it's a curve, and this will define a maximum. And positive, negative. Yes, positive, negative. And if you look at this, the gradient of this will be positive and the gradient of this will be negative, because this almost is like the demand curve that we know. So this will be this. So by studying the signs that we get from the second derivative, we are able to get an idea of what the nature is. So first, what I'll do is to get the second derivative. Second derivative, that will be d of that second derivative. That should mean second derivative should then be, now I integrate this, and it becomes 6x plus 6x plus 2. That's the second derivative. So we want to see what that is when x is 1. So at x is equal to -1, this becomes 6 into -1 plus 2, which gives -6 plus 2, and that is -4. We get -4. So because this gives us -4, we say hence x is equal to -1 is a maximum point. It is a maximum point owing to this sign -4. Then let's see, at x is equal to a third, we have 6 into a third plus 2, and this is 4, and that's positive. So we say at x is equal to a third, that is a minimum point. At x is a third, this is a minimum point, that is a maximum point. This is a minimum point, that is a maximum point. That's what we have. Let's see what we have again. Determine the equation of the tangent to the curve at x is equal to 1. Equation of the tangent to the curve at x is equal to 1. So it means this tangent at the point where they intersect with this curve, x is 1, that's for sure, and we can get y as well from here, and y is 1 plus 1, that is 2, minus 1, 1 plus 1, 2, minus 1, 1, minus 1, 0. So what we have is that at that point of intersection, that is y is 0, where they are making a tangent, where that curve is making tangent to just a minute, that the equation of the tangent to the curve at x is equal to 1, and x is equal to 1, we are the same. Did we find it? No, x was negative. So we change approach, we change our approach and say that at the point where we had at x is equal to -1, we had y is equal to, we had y to be 0, and dy dx at that particular point we had it to be what? dy Therefore, dy dx, at that point we add dy dx to be 4. Dy dx at this particular point is 4. How? Let's see. X minus 1, if we bring x minus 1 here, okay, dy dx, let me just write 3x squared plus 2x minus 1. So at x is equal to minus 1, this will be 3 minus 2, 3 minus 2, 3 minus 2 minus 1, 3, yeah, because x squared now will be 1 squared will be 1, so times 3, that's 3 plus this. So this is 3 minus 3, which is 0. No, that is not what I want. So let me figure out what it is. At x is equal to, at x is equal to 1, y is given as 0. Y is 0 if you substitute here. But then the question that we are asked is determine the equation of the tangent to the curve at x is equal to 1. So we have already set x to be 1 and we know that y is 0 at that particular point. So I need to see what the gradient is. So dy dx at that particular point, because I need the gradient for me to be able to specify the other gradients. So dy dx in that case becomes, because we add it to be 3x squared plus 2x minus 1. So if you substitute 1, I'll be having 3 plus 2 minus 1, which is 4. So I take the other point, an arbitrary point with these two values, and have y minus 0 over x minus 1 is equal to 4. This should then imply that y minus 0 is equal to 4 into x minus 1, and that should mean that y is equal to 4x minus 4. Y is equal to 4x minus 4. So that becomes the equation of that tangent. Then Roman 2 the equation of the normal to the curve at x is equal to minus 1. So we know straight away this is Roman 2. If the gradient here is 4, then we should be having 4 times m should be negative 1, implying that m is then negative a quarter. So taking an arbitrary point, y minus 0 and x minus 1, because we had the point, that's a point along the line, should give us negative 1 over 4. This implies that 4 into y minus 0 is equal to minus 1 into x minus 1. So I have 4y is equal to minus x plus 1. So 4y is equal to minus x over 4 plus a quarter. That's now y. Now not 4y. Y is now minus x over 4 plus a quarter. Now that marks the end of that particular question. So if you have a comment, please leave it down in the comment section, and I urge you to follow me to my next video.